to go through this so you guys can mark it and hopefully it'll make sense. Okay. No, this one. Right. So the first question, a car of mass 800 kilograms moving at 20 meters per second collides with another car of mass 1,500 kilograms, which is at rest. If both cars stick together, find their initial velocity after the collision. So, oh, it's not good. Right. So the first one is 800 kilograms and it's moving at 20 meters per second. The second one is 1500 kilograms and it's not moving. Okay. So we have before and we have after. And before is equal to after. So the mass before, or sorry, the momentum before is the mass times the velocity. That's the first one. And then the mass times the velocity. Second one is at rest, so it's not moving. And then after, it says they stick together. So that means the mass is that 2,300. And we don't know what the velocity is. So just V. Okay, so 800 by 20 is 16,000 plus 0 is just 16,000. And 2300V. And then to figure out what V is, we divide by 2300 on both sides. So V is, so it's coming up 6.96. The unit is meters per second, and since we got plus, it's to the right. So same as the direction the 800 kilogram was moving at. Yeah? Right, 6. A railway carriage of mass 6,000 kilograms. So 6,000 kilograms is moving at 10 meters per second. It catches up to and comes coupled with another carriage, 2,000 kilograms, moving in the same direction at 2 meters per second. Okay, so another one. Oh. Which is 2,000 kilograms moving at 2 meters per second. Becomes coupled means they stick together. So we have before equals after. So before is 6,000 by 10 plus 2,000 and it's in the same direction. So we keep the signs of the two velocities the same. Then they stick together, which is 8,000 by V. So 60,000 plus 4,000 is 64,000. And this is 8,000 V. Isolate the V by dividing by 8,000 on both sides. That'll cancel. And we get V is divided by 8 meters per second. And again, all of the velocities in this question were positive, which means they're all in the same direction. So that is also to the right. Is that all right? Okay, I'll move over here, I think. So question 7. A railway carriage of mass 6,000 moving at 10. So same starting point. So 6,000, oh, that's crooked. Sorry, third time lucky. No, it's fine. 6,000 kilograms moving at 10 meters per second. So you can just about see that. Collides with and becomes coupled to, so again, sticks together, a 2,000 kilogram mass again, but this time it's moving in the opposite direction of 2 meters per second. So it's still 2,000 kilograms, but it's moving in this direction 2 meters per second. All right, so same again, before equals after. So before they're two separate entities, so we have two calculations for momentum. It is 6,000 by 10 plus 2,000, and then we want to acknowledge that the 10 and the 2 are in different directions. So I've made the 10, by putting the 10 in here, it's positive. So that means right is positive, so that means the 2 is going to have to be negative. So it's going to go in as -2. After they stick together, which means it's 6,000 plus 2,000, so that's 8,000, and we don't know the velocity. So 6,000 by 10 is 60,000, and then it is 2,000 multiplied by -2, which is -4,000, so that gives me 56,000. And then the other side is 8,000 V. And we divide by 8,000 to isolate the V. And we divide by 8,000. So that gives us 7 meters per second for V. And the fact that 7 is positive means it's moving in the same direction as the 10, so it's to the right again. Okay, and then the last one is 9. Okay, so 9. A 100 kilogram block moves at 10 meters per second. Okay, so 100 kilogram block moves at 10 meters per second. It collides with a 60 kilogram block moving in the opposite direction at 15. So a 60 kilogram block moving the opposite direction at 15 meters per second. After the collision, the 60 kilo block initially moves with a speed of 8 meters per second in the opposite direction to its original velocity. Okay, so after the collision happens, the 60 kilo block does not end up on its side. Moves at 8 meters per second in the opposite direction to its original motion. And then the 100 kilogram, we don't know. Yeah? So this side is before, and this side is after. Let's make sure I read that right. After the collision, the 60 kilo block initially moves 8 meters per second in the opposite direction to its original motion. So it originally went left, so it's going to go right. If no external force act, find the velocity. Right. So before is 100 by 10. So I have just made the 10 positive, and the 10 is in this direction, which means right is positive. Yeah? So then plus 60, and the 15 is left, which means that has to be negative. Before equals after. So after we have the 100, and we have no idea. And we have the 60, and that 8 is to the right, and right was positive, so we can put the 8 in positive. Okay, so 100 by 10 is 1,000. 60 multiplied by minus 15 is minus 900. 100 by V is 100V. And 60 by 8 is 480. 100 take away 9, or sorry, 1,000 take away 900 is 100. And that's 100V plus 480. And basically we're going to go about isolating that. So if we minus the 480, it will cancel, minus the 480 over here. So that is minus 380 equals 100V. And then we're trying to get the V, so we divide by 100 to cancel the multiply by 100 and divide by 100 over here. So that is minus 3.8 meters per second. So the minus, if positive was right, that means minus was left. So the velocity is 3.8 meters per second to the left. So obviously they hit off each other. Like this goes this way, this goes this way. They hit off each other and they bounce away. So this bounces back and this bounces back. All right. Hopefully that makes sense. Let me know if you have any questions.